hate pencil.
Sometimes
I can't find my camera.
Oh,
Ani.
they're at temple.
the temple? On the temple?
They're at temple.
Alright.
Doesn't temple mean shrine?
Utara shrine is jinja.
Oh.
Now-
Same thing.
Building a chiga.
Sam, I want you to give this to everyone. Okay? So, yesterday, the first question we did, right? Did we?
Yes.
No. Eagle?
Yeah. We did it.
Okay, I asked you guys to do the question 2 at home. Did you do it?
Yeah.
Oh.
Alright. There might be various methods, but I'm just going to try on the board before we move on to the projectile motion. Okay? So, I already wrote few notes here, but before I start, I just wanted to, as a review, to do question 2 so that we can check whether you guys fully got it. Okay? Now, the only difference here, Megumu and Uihun, we are using the basic equations, but now we consider the directions. So we still have x final, x initial, average velocity time. But now because initially we always measure the x and whatever, the direction it moves. But now we are saying this will move, the velocity is to this direction. But we are trying to check how much is moved horizontally and vertically. So when we have a velocity, we always take the components to the x direction, which is Vx. Y direction. After that, we follow the same method. So for the x direction, when you are finding the x, we are saying xf, xi, v, xt. When you are finding the y direction, y final, y initial, vyt. Is that clear? So for every basic equation, we now consider the direction. So we take the component. Up to here you guys are clear? So that's what we discussed yesterday. Okay? So doing the second question, a hummingbird is flying in such a way that its initial moving velocity, because initially moving with a speed of 4.6 meter per second. Okay? So this hummingbird, the initial speed is I'm sorry guys, this is kindly printed in a funny way, but a hummingbird is flying in such a way that it is initially moving only vertically. So it does not have initial x is what? What is your initial x speed? 0. Because it only have initially y, which is equal to 4.6 meters per second. The funny thing is, this hummingbird, although it's moving vertically, the acceleration is horizontal. So your ax is 11 meters per second square, but ay is equal to 0. Okay? So now you are finding the horizontal and vertical distance which it moves within 5.5 seconds. Okay? So we are trying to find how much it moves. It tries to fly like this, but because acceleration is to this direction, it's finally moved like this. Okay? So we are trying to find vertically how much it moved, horizontally how much it moved. So when you are trying to find with the time, we will use, remember the distance and time. So x final is equal x initial plus Vix t plus acceleration t square, right? This is all to x directions. If you want to use y final, y initial, velocity initial to y direction, t plus half ay t square. Okay? So when we want to find the horizontally how much it moved, we can use this equation. Do you all agree with that? So we are finding here xf is equal, what is your initial distance? 0. What is the initial velocity to x direction? 0. What is do you have acceleration to the yes, what is that? 11. And time is 0.55 square. Right? So you can get your final x. Got it? Whatever value you get here. Then after that, yf, what is initial y? What is initial y here? 0. Do we have a speed to y direction or velocity to y direction? Yes. What was that?
4.6.
4.6. T is 0.55. Do we have acceleration to the y direction?
No.
No, because our ay is 0. Okay, so this doesn't matter. These are all going to be 0. So your yf is 4.6 and xf half 11.5 square. So you can calculate this in meters. Got it? Do you understand what we did here? Okay. Now, Megu and got an idea? So it is, then we have to find its x and y velocity component at t is equal whatever 0.55x. Okay. So after the time is 0.55x, we are finding our v final x, v final y. Is that clear? So which equation is the best? What is the best equation? Remember we learned v final is equal v initial acceleration time t. We learned that, right? Now we are using into two directions. So we can say, can I erase this part? Gracie and I erase, okay, can I erase this? So we can now use, the basic is this, v final, v initial, at. So final to y direction, initial y direction, ayt. But the good thing is this is 0, right? We don't have acceleration towards the y direction. So it's going to be same as initial y. So after 0.55 second, y is same as initial. So which is going to be 4.6 meters per second. But for x direction, did we have initial speed for x direction? Did we have x direction? Do we have initial velocity to x direction? Do we have any initial? No. So this is 0 plus ax is, what is ax? What is the acceleration for x direction? 11. So this is going to be 0 plus 11 times 0.5. So you are getting your, after 0.55 is gone, your Vy and Vx. So you only have, this velocity has not changed because there was no acceleration. Even after 0.55, y direction velocity has not changed, but you have a velocity to x direction. Got it? Hello? So what is the value here? I don't know what, when you calculate.
6.05.
Sorry?
6.05.
6.05. So when the time passes at 0.55 second, your velocity to this direction is 6.05. This direction is 4.6. Right? So is that clear? Are you guys okay? Uni? Jimmy? Yes.
Well, we multiply by half, and
We don't multiply by half because there is no half in our, because this is the velocity equation, this one. Vf is equal to di. Okay? So, now we can find, how do we can use the Pythagorean, right? If you want to find the final velocity. We only found the x direction and y direction. That is what question is asking. But you may want to find and see where it actually directing. Got it? So this is 6.05. So this is going to be 6.05 squared plus 4.6 squared. Yeah, that's the velocity, final velocity. Because we got only the components to x direction and y direction. But we can find the magnitude this way. Can we? Because then we can give theta is tan inverse 4.6 over 6.2. You can finalize the velocity that way. But your question, you are only asked the components. Got it? Now, I know those who are here can follow quickly, but how about those who are not here? Do you understand what we did here? We will. Fine. Nagato. Yes.
just checking that triangle isn't connected to the graph.
No. It's not proportional. I just draw. After 0.55 second, our x component is this, y component is this. Okay. Alright. So that is what we were basically doing. So we are now putting together the vectors and the motions. We learned chapter 3 vectors, how to break your velocities into two directions. Now we are using them to calculate. Is that okay? So can I then move to the main part, projectile motions. Okay? So I already wrote the notes here. There is not big deal. Only thing is, projectile is an object that is thrown or launched or kicked or battered or anything, but it is only subjected to, when it is moving, gravitational force, nothing else working on it. Okay? Of course it can have initial speed, but we are neglecting the air resistance, and we also neglect earth rotation. So we don't calculate those magnetic fields and all.
Oh my God.
Only the y component, yes. Unless you are given another acceleration. But you have to now assume there is always gravitational force. Okay? That's what projectile motion is.
Mr. September, will you do this for us too? When we're gone?
You are going somewhere?
Sorry.
This is, Mrs. Irvin decided to record it, so you can ask, I think Abby and who else, when Julie. Probably they ask, they want.
Yeah.
So you can ask.
We can watch it.
Right? But when you guys are going, probably you are mostly doing labs, I think. I'm not sure. Okay, so let's go on to the projectile motion. Now this is also not new because you have already done without 2 dimensions. So you know how to do this, okay? So now let's say if you are dropping something from a top of mountain or somewhere. So when you are let's say you are standing here, this height is probably, let's 10 meters, and you are standing, and your height probably is neglected. Altogether, let's say 10 meters, okay? And you are throwing a ball, whatever, okay? So when you are throwing a ball, you can throw this direction, or this direction, or this direction. Horizontally, or just throw down or throwing upwards, either way doesn't matter. But according to the direction, according to the angle where it lands is different. And the time it takes to land is also different. So we are going to find out that. Okay? So let's say, as an example, you throw the ball 6 meters per second horizontally. First, number one, you are just throwing it horizontally. This is number one, okay? Number two, you are throwing it at the angle of our favorite 25 degrees upwards. Number three, you are throwing it 25 degrees, or let's say different degrees, 35 degrees down. Now let's see how does it move, how much time it takes to land, all that. Okay, and what is the path, all that. Okay. So number one, you are just nicely vertically throwing it. Okay. But as you all are comfortable to take 0, 0 here, I'm going to use 0, 0 in the ground. Okay. The first one. This is where you are standing. Initial position is 10 meters. Right? So xi is equal to what? What is xi is equal to?
0.
0. yi
That's 10.
10. Y final?
That's 0.
0. X final? We don't know. We don't know where it's going to land. Okay? So when you write it down these things, I don't think it's going to be very hard. We are only doing the very first one. Okay? So initial velocity is toward to what direction? Because you are throwing horizontally, it is to the horizontal. So we only have x direction. So V initial x is 6. V initial y is? What is V initial y here?
0.
Do you agree that it is 0?
No.
Because this one is only horizontally. I'm only doing the first one, okay, number one. This is number
0.
one. Okay? So let's find out how much time it takes to get to here. Okay? Now, where does the acceleration work? Upwards or downwards? So G is always negative 9.81 meter per second square. Okay. So to find the time, what is the best equation you can use here? What equation would you use to find the time?
When it
The Vx squared equals Vi squared.
But we don't know the final velocity. Which equation would you pick up?
Then the x that equals xi.
This is the equation, but we are using y here. Okay? The basic equation is this, xi plus vit plus half at square. But we are using, this is our basic, let's use the y part. This is our, long ago we learned that. I should have not used x that time, distance. Then we can easily break x and y, right? Now you are getting confused, why is x? Okay? We are finding the distance and time relationship. But we will use towards the y direction because we have this length. Do you understand? This height we have, do we? Yes. We all agree. So y final is equal y initial plus vi to y direction t plus half ay t square. Now y final, where is y final? What is it equal to?
0.
0. Y initial? 10. What about velocity to y direction? 0. So this is going to be 0. Half, what is AY?
Negative 9.81.
Yes. Do you all agree with that?
Yes.
Acceleration is negative 9.81 and t squared. So we only don't know t, we can find our t here. Right? So 9.81 t square is equal 20. T is equal square root. Just put it to the calculator and find it. Because we consider positive as upwards, right? That's why this was positive. So, but got it? Now what is t here? 1.428.
1.428.
Let's say 437. Okay? So it takes 1.43 seconds to hit the ground. Now let's see how far it hit from here. Okay? So we will use x final, x initial, Vix, t. So there's no acceleration to this direction, right? That's why I'm using this. Oh, let me write it everything. Half Ax. That's better. Instead of using. So here, do we have acceleration to x direction?
Yes. No.
No. There's no acceleration. Only gravitational wave. Okay. Xi is 0. What is this? Velocity to x direction. Do we have a velocity? 6. T is now 1.43. So you are getting the meters. So it hit something like this. Right? Can you find the velocity when it hits? So what is this value? Let me answer that. 8.58. So it moved from here, let's say 8.6 meters. Right? Can we find the velocity of x component and y component when it hits? Go ahead and find. Which equation is the best here? Yes, that would be the v final square. V final y square. V final. I don't like to write fy, look like a function there. Okay. Vy final square, Vy initial square plus 2ay delta y. Right? Okay, got it? Sophia. Uni, you are fine? How about my 10th graders? You all? Judy? Okay. So, we are looking for this. Do we have initial y value? No. This is 0. To the y direction, there is no velocity at the beginning, right? 2. What is your ay? Negative 9.81. What is delta y? Is it 10? No.
8.6.
Y final minus y initial, right? Negative 10. Because y final is 0, initial is 10. So this is negative 10. That's why this is nicely becoming positive. 20 times 9.81 square root is the final y direction. Okay, so when it hits, you have velocity to this direction and this direction. Okay. So can you find the same maybe x direction at the end? That's fine, right? Okay, so this throwing horizontally, you are okay. Now let's try the second one. Now you try by yourself. I did the easier one, you are going to do the hard. The best thing is, guys, before you do write all your components, that makes things easier. This is 10 meters. Now you are going to throw it at an angle. So your Vx is going to be 6 cosine 25. Vy is to this direction. Is equal to 6 cosine, sine 25. You know, I know, I don't know whether 10th graders, you guys didn't learn yet. Did you learn in pre-cal sine 2 theta and tan 2 theta? Okay.
Sine law?
Yeah, like, do you know if I put tan 2 theta, do you know that this is 2 tan theta over 1? That's fine.
Do we need to memorize all that again?
You need to have sometimes this trigonometric relationship. So, do you remember? Do you remember these functions? Are you okay?
Yeah.
But in AP Calc, you are given in the sheet, right?
We are.
The printed part?
In the equation sheet.
You have to memorize? You did not.
We did.
You had to.
We used to.
Yeah, let's keep that memory. Because it makes things easier when you want to calculate harder questions.
It's like the double angle theorem, half
Double angle theorem,
theorem,
half angle theorem, and
Pythagorean
angle
theorem
addition, cosine A plus B
is cosine A, cosine B plus sine A, sine.
minus, right?
Oh yeah, minus.
So probably it's better to have them. I will try to print it, and but I don't want you to depend on it. Just I don't know whether in AP Physics that you are given all relationships. I don't think so. But there is only one question that was like that, so you had to use it in this section. So that's what I was thinking. But basically, you don't have to use it. Okay? So let's try this. Okay? You are going to do it by yourself, I told you. So I also want you to find out how far it goes up first. Right? Other seniors would be so tired.
I have a long one.
Oh, it's like crazy.
Can I go wash my face?
Yes.
Can I go wash my face too?
Let's go wash our faces.
Can you wash my face for me? You know? That's
The brain is not moving.
It is.
It is. So go ahead and do that. First, you may want to find how far it goes up here. What is the distance from here to here? Find that far first. Hey, John. Go ahead. No. I want you to find it. To this direction, it's 6, right? The angle is 25 degrees, right? Now you are going to find how much higher it will reach before it drops. What do you use? How do you find that? In order to find this height, what do you need to know here? You don't need to know. You should assume. You should know that here what's happening. What V is zero? Vy, this is zero. The velocity towards to upward is zero. Maybe hit here. Okay, so the velocity to upper direction, y direction is 0 when it comes to the top. So you are using here V final at this point. Is 0.
Here we go.
Right? So we are saying Vy final is squared is equal Vy initial squared plus 2Ay. We don't know this delta y.
I knew it.
This is 0.
I knew it.
This is 6
Yeah.
sine 25
I can't connect this with
Okay.
derivatives.
2 negative 9.81, and let's find delta.
Oh, so is it like, oh,
So you're
wait.
basically using the idea that when it's hitting the maximum point, that's when velocity is 0.
Velocity, this
Oh,
y direction
so
velocity.
wait, so does it mean if you ask for the velocity at a point, you just have to get the derivative of the slope, then you get the tangent line? Okay. It's not derivative.
So can you say that again?
This is a parabola, right? So what happened here, your tangent, so you are making tangent, here the tangent is dy by dx is equal to 0 at this point. So at this point, your derivative is 0
Yeah, because
it does not
There's no
have a
slope.
tangent. Tangent is horizontal now.
So why did it do?
For what? Yes, from here to here. Maybe it only go that much. Probably, I'm not sure. Let's see. Did you use this? 10 point?
10.33.
So from here to here, 0.33.
Oh, if you don't add 10.
Yeah, you add afterwards. Yeah, that's right. That's okay. So from here to here, it's only 3. But otherwise, it's 10.33. That's good. Yeah.
is that when, so is 6 cosine 25 when x is, it only moves 1 second?
Sorry.
Right.
No, I am just finding, I didn't find time yet. I'm finding how much high it goes before it fall down. Because you are throwing this way. This, look at this. If I'm throwing like this, it won't go up, right? But if I'm throwing something, it first goes somewhere
Oh.
further up and then it drops, right? So that is the distance I'm looking for.
So does it mean that,
What are you,
no, I don't know why it's, oh, because the
here
velocity-
your velocity component Vy is equal to 0, right? There's no velocity. So we can find this distance or this height, how much it climbed before it dropped. Okay, I just added that one. Okay, now you are going to see how much time it takes to hit the ground. You don't need this to do that, but I just want you guys to see when you are drawing, you need to realize it goes like this. Right, it's nice.
Oh.
But it is going to go 10 meters down. So let's write down. What is the best here? Which one would you use? Again, y final is equal y initial plus Vy t plus half Ay t squared, right? But this is now what is y final? Your y final is? Y final is 0. Y initial is 10. What is Vy? Do we have Vy component? Yes, because it's initial 6 sine 25, right? Is that clear here? Hello? 6 sine 25 plus whatever value t here, okay? Guys, you need to recognize that you are going to find the value here using your calculator.
Like, I don't get how 6 sine 25 is the velocity.
Yeah, I don't get that either.
How what?
I don't get.
Y component
I
here.
I can't understand.
Because that's isn't that
I get the math,
isn't
but I
it
don't
6
get
sine
why.
25 when the hypotenuse is 6 but if it's more than if it moves more than 1 second, then wouldn't it change?
I think NJ doesn't remember the first one.
This part here.
So
We are doing the second question.
Yeah.
Years per second.
それわかる。
え、だからそれでさ。
We understand that. だってそこが6 meters ってことはさ。
Where 6 meters? No, it's not 6 meters. It's 6 meters per second.
Yeah.
Per second, it travels 6 meters this direction. But remember, it does not travel 6 meters because there's a gravitational force working on it. If there's nothing, yes, it will nicely go 6 meters. But it is hindered by this other force. Is that clear? That's why we are using this equation. We can't calculate, because there's acceleration working on that. If this is 0, it will go 6 meters nicely. But since there's acceleration, no, it won't go 6 meters.
The reason why you do 6 sine 25, 6 cosine 25 is you're breaking
Into y component. Okay? So, we can also use the x component to check where it hit, right? Can you see the x component here? So if you take the x component, guys, what do you get? Do you have acceleration there? So you can find the x direction already, right? Hello? Okay. Do you understand why I use this? Because we have 10 meters here, so you can, but this is getting a quadratic equation. Do you understand? So y t is equal yi, which is your 10. This is 0. What is this? What? 6 sine 25 t. Okay? But t we don't know. Plus half. What is your ay? Negative 9.81.
Dy equals 6 times 25. Does it mean 6 times 25 per second?
Okay. Now it's a quadratic equation, yes.
No, y equals 6 times 25. Is it that per second?
That's per
Wait, so
this
is
yes,
it
this per
6
second.
times 25 per second?
Second, yes.
Oh, okay.
Yes, this is a velocity. This is meters per second, yes.
Okay.
These are still meters per second. They
Okay,
are all
okay,
velocities.
okay.
Got it?
Yeah. Oh. それは増えた。
So can we find our t from this? Now this is a quadratic. And you have the quadratic function nicely, right? You just have to put the values, you get your t beautifully. So
1.71.
t is 1.71.
Yeah.
Did you all get that? T is 1.71. To hit the ground, it takes 1.71.
But that's regarding. Oh.
Because that's why we use this 10. Got it?
Yeah. But why did you you remember the first question was how long it takes to reach the actual height there?
I didn't calculate the time. We said we just calculate how much it go higher. We didn't calculate the time. We can calculate that time very quickly. Okay?
So we think together, right?
Yes.
Like this part and this part
But
all
together.
together.
Yes, all together. That's why we use this 10. Okay? So when the t is equal 1.71, how far it goes from here? Now what do you do? X, yes. So X final is equal X initial plus Vx Vix, okay? T plus half Ax T square. Do you have Ax? Do you have acceleration to acceleration? No. So this is 0. This is also 0. Do you understand? We are measuring from here, right?
Yeah.
There is no xi. Xi is equal 0. But Vi is what? 6 cosine 25.
XF is also 0, right? Oh.
No,
you don't
XF
know.
is
Oh,
there.
right. You don't know.
XF is somewhere here.
You don't know, right?
This is, that's what we are finding. T is what? 1.7. So that is the distance it hit.
Oh. So like the T you got from Y will be applied to
Applied
X.
to find X. Yes, we have. Because we are measuring from here, see? This component, this is 0, 0. This is 0, 10. Now this became, whatever value you get here, something 0. I don't know what value.
We got all from
9.3.
Why is the 10?
So it will go 9.3 from here.
usually like only 1 or 2
Right.
a year. Like any
In this case, your Vy is positive. Do you understand that? Because it's to this direction. Hello?
Yes.
In third one, you can do without a trouble now, can you? Because you are doing the same thing. But I would like to see whether you can find how much time does it take to come to the same level.
Oh.
Can you find the time
Probably.
up to here?
Right? You can, right?
You can, of course you can.
So you
Time from here to here.
So you would say like X. I mean YF will be 10. YI will be 10.
Yes, both are zeros, right? But what the best is, do you know the time takes up to here and double that? You can find this time, right? For your Vi to become 0, what is the time? And double that time. Do you understand that part? If you want to find the time from here to here, find the time that Y final, the time taken for V final to become 0. So if you find this time, you double it because this is a parabolic curve. It's a parabola, right? Yes.
When there's no air resistance.
When there's what? No air resistance, yes, of course. But remember, we are assuming there is no air resistance. Yes.
So I want to refer back to the 0 equals 625, this square one. If you solve that, you get the difference. You get the delta y, right?
Yes.
Then
That is here, right?
so the answer was 13.2. So that would be 13.2. So the total height would be 23.
Did you get 13.3?
Yes.
When you simplify this is negative.
You added shit.
You already added 10?
Then you just have
This is 0.
It's not called like
6.25 square. I'm not sure.
Is the delta y squared too?
No.
I think you could.
What?
0.
6 times 25. O squared there.
Divide by 2 times 9.81. That can't be. Because sine 25 is less than 1. So if this is less than 1, this is less than 36.
Sine
And you are dividing it by something by 18.
Wait, Kazma, what's your problem?
What is that? I think you're in reading.
Yeah.
How do you
Change the degree.
Okay.
Degree of it. Gradient changes to
Degree.
Different, it's in the green.
Let's see. So 6 times sine is 2 So this square this.
Dude, don't take everything like that way. Like even yesterday, you're like,
Because we are finding t.
I was like,
So we are making it to this side.
yo, that was totally accident. Like,
See, when you are doing it,
I'm like, like
You
it's
see,
like
this is
I
going to
was
be
so
equal
like
to
into it that I forgot that it's wrong. I'm like,
9.81 is equal 6 sine
And you're like-
25.
I'm like, oh.
Delta 1. So your delta 1 is going to be 6 sine 25 square divided
Girl, girl.
that should be less than. Okay, that is this side. Okay, so you have how many questions? 2 questions here for the weekend. And orange paper, you have 2 more. Altogether, you have 4 questions. Homework by Monday, bring it because otherwise we are not moving. Only 4 questions. If you can do those 4 questions, you are fine. It's not in item?
It's in the email. 와,
So when you first did this one.
This one to the sauce.
When you